Hello everyone, this is Dr. Willow Ariella coming to you to talk about designing, conducting, analyzing, interpreting experiments of two groups. We're talking about Chapter 10 in Smith and Davis. So I wanted to share some thoughts with you regarding this chapter on experimental design with two groups. So the authors discuss the experimental design that was outlined in Chapter 1, and they go into some different ways to conduct an experimental study. And so in experimental design, we're talking about two groups, a control group that does not receive the treatment and a experimental group that does receive the treatment. So they're talking about the two-group design first, and the authors discuss why that is such a basic and good design, and they talk about Occam's razor, or the principle of parsimony. And so they're suggesting that the principle of parsimony, or Occam's razor, applies to research questions. Don't needlessly complicate the question you're asking. So to simplify your research design using the two-group design is often the simplest and might be the most effective for your research. Not always, but they're discussing why the two-group design may be the best and for the purposes of this discussion. And so they provide a helpful table or figure, 10.1, about how many independent variables are going to be in the research. And in this chapter, we're just discussing one independent variable. And if you have one, then there are different participant groups that you can choose. And so they go into detail, which we'll discuss, or I'll discuss, I suppose. So they review some basic concepts like independent variable, dependent variable, and how many groups to have. So we're assuming two groups and one independent variable. Why is that? The reason why we have two groups and one independent variable is because that's the simplest way to see if our independent variable actually caused a change. And it's one of the best methods we have to control for extraneous variables. And just to mention, extraneous variables, Smith and Davis talk about this too in this chapter as well as other chapters. Different people, different researchers, different textbooks will call variables that affect the results with different words. And some of them are similar, some of them are the same, some of them are not the same. So it can be confusing. They mention extraneous variables, they're uncontrolled variables that can influence results. And later on, they'll discuss other kinds of variables like confounding and things like that. So just keep that in mind, that anything that can affect your outcome can be anything that can interfere with the results of your experiment, your testing, can be called lots of things like extraneous variables, confounding, that sort of thing. And we'll go into those in more detail later on too. We have the experimental group, the control group, and then the authors discuss assigning participants to groups and when that's helpful to do. Random assignment. So random assignment, the purpose, the main reason for using random assignment is because if you do random assignment correctly, then all your participants or subjects should be randomly distributed into your two groups, experimental control group, which means that any differences that may be in the groups should be evened out or balanced or equal. Should being the operative word. It's not perfect. There's nothing perfect in research. Random assignment is not perfect. It cannot control for everything. And as Smith and Davis discussed, the size of the groups, that's a factor too. But random assignment is an important way, generally speaking, to distribute the possible differences in your two groups. And so that's one reason why it's such an important tool or aspect of research. And so random assignment can be done in many different ways. Like they mentioned, flipping a coin. You can use computerized randomization. There are different ways to do random assignment. Flipping a coin is one of the easiest, but if you have a large group, then there are computerized methods to do that. So random assignment, that's used to help distribute any possible differences in your two groups. They mentioned that random assignment is not the same as random selection, so you don't want to get those two confused. They are not the same. Random assignment and random selection are not the same. It's getting a little dark, so I thought maybe I'd move closer. Random selection is a different kind of control technique. And you want to be sure that you look at the difference between random assignment and random selection. And review that in Chapter 6. And then they talk about terminology. So they say terminology, this is on page 208, terminology in experimental design can, and all research actually, can sometimes be confusing, and that is so true. Unfortunately, literature review can mean a lot of things to different people. Reviewing the literature, research, experiment, study, extraneous variables, confounding variables, so unfortunately, like Smith and Davis said, there are a lot of terminology is not standardized. For example, when I was in grad school, we learned that there is a significant difference between administering questionnaires and survey methodology. But nowadays, I don't see that differentiated. So, you want to keep in mind that sometimes the terminology can be confusing, and ideally, in your research, in your write-ups, you clarify for your readers, your audience, what you mean by the terms. So you want to be clear whether or not you're using random assignment or random selection and that sort of thing. So, and they also point out the key to avoiding confusion is to understand the principle behind the strategy of random assignment or anything else in research. You want to understand what people are saying, and hopefully they're clear. If they're not clear, then they are not communicating well what they mean, or they've used a procedure in a way that is not, may not be appropriate for that research study. So random assignment is important in experimental design as a control factor. So we can usually assume that our two groups will be equal on a variety of variables, but not all. You cannot, it's impossible to control for every single one. That's why the larger your group, the better, generally speaking, because you have more participants or more people to help better control for variety. Smaller numbers, there's less, more possibility for things that are different in the participants. The more participants you have, the more you can rule out variety in those participants of the impact on your result or outcome. So they say that we can usually assume that our two groups will now be equal on a variety of variables, but notice that they don't say all of them. Many of these variables could be extraneous variables that might confound our experiment if left uncontrolled. Random assignment is one of those statistical procedures that is supposed to work in the long run. However, there are no guarantees that it would create the expected outcome if we have a small sample. So, they mentioned an example of flipping a coin. Thus, when we randomly assign participants to a group, we expect the two groups to be equal on a variety of variables that could affect the experiment's outcome. But it won't control for all variables. And then they discuss confounded experiments. And mentioned that in this particular study, McClellan and Woods, unfortunately with the confounded experiment, there is no way to determine which conclusion is appropriate. If they conducted their experiment in the manner that confounded it, they would have wasted their time. And unfortunately, there's a lot of research out there that is really a waste of time. So that's why this class is so important. We want to understand what's behind these methods and which ones are of value. So they say random assignment should equate any differences between two groups, generally speaking, and assuming your group size is adequate. They ask a good critical thinking question. Can you think of a flaw in McClellan and Wood's reasoning behind random assignment? So they discuss small group sizes. So then they talk about what you can do when you conduct an experiment with small numbers of participants, so non-random assignment to groups. And they discuss a term called correlated assignment, or better known as matched or paired assignment. I'm more familiar with the terminology matched or paired assignment. And so pairing or matching, when you have a small number of participants, you match them on certain variables. So they do say, and I want to emphasize, be careful, correlated assignment has nothing to do with computing a correlation coefficient. So that word correlated assignment just means that something about those participants are related. So they discuss matched pairs and how you create a matched pair group. They ask a good critical thinking question. In what way is matched assignment guaranteed to create equal groups when random assignment is not? And they discuss the beauty of matched assignment is that we have measured our participants on a specific variable that could affect their performance in the experiment, and they've equated them on that variable. The tricky part is that you may not know what could affect something in those participants that would affect your results. So if you cannot measure participants on a variable that is relevant to your performance in your experiment, you should not use matched assignment. And if you do, then you've actually hurt your chances of finding a significant difference in your experiment. And then the repeated measures is another method for matching or pairing, using the same measurement or testing with the same participants in both treatment conditions. And so they serve as the participants serve as their own controls. And then they ask a good critical thinking question. Why is it not possible you use repeated measures in all experiments? And they give you 3 good reasons. Sometimes you just can't do it for your particular study. And one of the important ones is C. Can our participants cope with repeated testing? People only want to be a participant for so long a lot of the times, and at some point they're going to get tired, and their tiredness is going to impact your results. Researchers have to think of all of these things before they figure out which design they're going to use. And then they have natural pairs as another way of matching or pairing. But natural pairs, you have to make sure that it's defined. How you, as a researcher, are defining natural pair. Is a husband and a wife a natural pair? That would depend on your definition of natural pair for your study. So they discuss within subjects comparisons, when we wish to compare the performance of such participants, the correlated groups design, we are making what has traditionally been known as within subjects comparison. We are essentially comparing scores within the same participants or subjects. And then they discuss repeated measures and a particular study that a student conducted. And they're re-emphasizing that matching should occur on a relevant variable, one that can be an extraneous variable if left unchecked. So that's really, really important. So if you don't know and you try matching on something that really isn't relevant to your study, then that can affect your outcome. And then they go on to comparing two group designs. So because there are two different two-group designs, researchers must choose which one to use. You may be wondering, how do researchers make such a choice? That's a really good question. How do they? Any ideas? So they discuss some different ways to think about that. So they said, you may remember we said that random assignment is supposed to work, i.e. create equal groups in the long run. The next question, of course, is how large is large? How many participants should be in the group? Unfortunately, there's no specific answer to this question, and the answer may vary from researcher to researcher. There is a table that I used in grad school to determine how many subjects or participants needed to be in a particular study, that it's still ultimately up to the researcher to defend their decision, and the number of participants depends on the research question. So generally speaking, the larger the better, the larger up to a certain point. After a certain point it doesn't matter, and they discuss that later. They also say part of the answer to the question number boils down to what you feel comfortable with, what your research director feels comfortable with, or what you think you could defend to someone. Defending means, what is your evidence for saying that this number of participants is adequate and won't affect your outcome. Whatever you decide, it's critical to remember that the larger your samples, the more likely random assignment is to create equal groups. So yeah, the number of people in your study is a significant question, and typically the larger the better. Then they talk about the advantages of correlated groups design and control issues. When we assume that our groups are equal, then we can attribute the differences in our results to the independent variable. And then they get into having proof that our participants are equal beforehand, which relates to random assignment. So then they get into statistical issues and talking about maximizing the between groups variability and minimizing the error within groups variability. And so they discuss that what it all boils down to is that your statistic is going to be better, I guess is a word, if you have maximized the between groups variability, so your treatment and control group, and minimize the error of the within groups variability, people in your groups, you'll get better results. But that little thing at the bottom, page 215, that's a big generalization, but it's generally true. So your statistics will be better if those are kept in check, essentially, minimizing the error or within groups variability and maximizing the between groups variability. And then they discuss some aspects of shoulds. On page 216, they have a paragraph, and then underneath the paragraph, why do we use the hedge word should 3 times in the preceding sentence? I mean, that's what research, unfortunately, research has a lot of shoulds in it, and maybes, and mights. It's always going to depend on how good it is, how good the study is, how good the design is. All of these factors come into play. So, you have a lot of, can have a lot of variability in research if certain things are not appropriate. So I thought that was pretty funny. We talk about degrees of freedom. Don't let that freak you out. It's a strange kind of concept, but you'll learn more about it in statistics class. You just need to know the basics about it, and they describe it well enough for your purposes for this class. The advantages of independent groups design. The chief advantage of independent groups design is their simplicity. So once you plan your experiment, choosing your participants is easy. You just get a large number of people and randomly assign them to groups. And then they talk about when or if the statistical advantage of correlated groups design renders independent groups design useless. So sometimes that's important. As the number of experimental participants increases, the differences become smaller and smaller. But at a certain point, it doesn't matter the size. Remember that in some situations it is simply impossible to use a correlated groups design. So, if you can't, you can't, and you do your best. They say, so what is the elusive conclusion? As you might guess, there is no simple all-purpose answer, and that is unfortunately the case with research. There is usually not one all-purpose answer. Research is complex and complicated, and so the better you can understand the different terminologies and things like that, the better your research would be, and the better you can understand whether or not someone put together a good research study. So it is complex, and there isn't a one-size-fits-all. So the better you understand these different concepts, the better you can be good consumers or readers of research and conduct your own. So they say, for all those in-between cases, you must weigh the alternatives and choose the type of design that seems to have the greater advantage. And how do you figure that out? You do a good literature review. Then they talk about variations on the two-group design. They mention the key point to notice when we conduct an experiment contrasting different amounts of our IV is that we no longer have a true control group. In other words, there is no group that receives a zero amount of the independent variable. Again, we are not trying to determine whether the independent variable has an effect. We already know that it does. We are merely attempting to find a difference between differing types or amounts of our IV. So they're talking about comparing different amounts of an IV or independent variable. So what commonly happens is that a researcher will have a question like, does something affect something? And if there's no previous research, then typically they'll do a preliminary study. Sometimes it's a small sample size, but sometimes it's a big one. But they want to find out first, does X affect Y? And then they would do, likely, depending on the situation, a follow-up study. If X does affect Y, then they would want to know how much. So this is a really common process. First you find out if something affects something, and then you find out how much does it affect something. And then an experimenter or researcher may take another aspect of that and kind of tweak it. And well, if this different kind of group, or different sexes or different ages, or whatever, what kind of effect does the independent variable have? So that's a really common process, to start with a kind of general research question: does X affect Y? And then dig a little deeper on succeeding experiments. And then they talk about ex post facto research, where you cannot manipulate the independent variable. So they provide a good example of people with and without ADHD, because you can't make people have ADHD. So that's a good example of an ex post facto research design. You can't draw a cause and effect conclusion on ex post facto research, but that's not always the goal of research. Sometimes you just want to know if something exists or not. So then they go into statistics and calculating statistics. They look at analyzing two group designs. So this topic of experimental design requires a t-test to analyze the resulting data, assuming you have interval or ratio level data. So if you're forgetting what those concepts mean, review those. And they have a good paragraph. I'm looking at page 221. A t-test is indicated as the appropriate statistical test because you conduct an experiment with one independent variable that has two levels. The decision of which t-test to use is based on how you assigned your participants to their groups. If you used random assignment, then you will use the t-test for independent samples. If you use repeated measures, matched pairs, or natural pairs, then you use the t-test for correlated samples. The question is, for you to think about, is why? And then they give a sample study about customers who wear sloppy clothes and how quickly people assist them. Which statistical test would you use to analyze data from this experiment, and why? So that's a good question to ask yourself and see if you come up with the answer on the sloppy clothes experiment. So which kind of t-test would you use? And then they talk about making sense of your statistics. And I want to emphasize something that they wrote. Statistics are not something to fear and avoid. They are a tool to help you understand the data garnered from your experiment. So maybe some of you have already taken a stats class and you have a good understanding of some of these concepts that are discussed in the remaining chapters. And maybe some of you have not yet taken a statistics class, and that's fine. But I do want to encourage you to think about stats as a tool. If I can learn it, so can you. So they are learnable, if that's a word, and they are not foreign to be feared objects. They are just a different language. And so it's just becoming familiar with the language and thinking about using critical analysis to think about what they're about. So just as having a sewing machine is useless if you don't know how to operate it, statistics are useless if you don't know how to interpret them, and that is very, very true. I was a research assistant on a very large questionnaire study, lots and lots of data, and it got overwhelming to me. So it took me quite a while to figure out how to work with such large amounts of data with my whatever professor, I forget his title, but anyway, so you know, it's a process. It really is a process of understanding. So they discussed, you know, some concepts about reading statistical information, and they review the tables in here quite nicely. They do make a comment that I want to reinforce: garbage in, garbage out. If you're using a Excel spreadsheet or any other kind of tool to do calculations, you know, simple addition, subtraction, multiplication, percentages, whatever, and you put in the correct numbers, you're going to get incorrect numbers out. So they remind you, I remind you too, to double check your information. It's a very smart thing to do. And it's helpful if you can do some of it by hand. They suggest that you calculate, for example, the mean. The mean is very easy to calculate with a calculator, so if you can double check your computerized output on some things that are fairly easy to do, then that can help you ensure that you put in your numbers correctly. So they go over some concepts about statistics, like homogeneity of variance, heterogeneity of variance, and what those mean. They talk about the F statistic. So just reading those, and it can take us a few rereadings and really looking at the tables to get a sense. You know, these concepts are relevant and important, but they're not critical at this point for this class, but it's helpful to understand them so that you can know what these tables mean and how to read information in research reports that you'll be reading. And they talk about robustness of t-tests. And so researchers or statisticians have looked at different statistical procedures like t-tests, and have, you know, done testing with different kinds of data, and they talk about the robustness. If you don't have homogeneity of variance, then the t-test can kind of have some flexibility, I guess. You know, if your data is not too wildly out of shape, then the t-test is robust enough to still be of use or value with your data. And then they make an important point that I want to emphasize. For some reason, people think that, you know, you can show a table or show numbers or whatever, and you don't have to talk about it. But APA requires that you discuss your data. You need to write it out in words for your reader. So you can't just have a table or have of whatever you have, a histogram or anything else, and leave it at that. You have to write your statistics into words in your report. It's an APA requirement, but it's also helpful because that way you're sort of double checking yourself and your readers can check you as well. They ask an important critical thinking question on page 224. Why would this conclusion be incomplete? Can you develop a complete conclusion before proceeding? So you might want to read what's up above that blue critical thinking box and see what you come up with. And so they describe how you would communicate statistical information, giving a clear accounting of the findings so that people can read and also understand your data. They talk about positive correlations and negative correlations. And so you want to take care in making cause and effect statements as compared to correlation statements. And again, they're going into translating your stats into words on page 227. They point out that the research study that they have gone into detail is a hypothetical. And then negative correlation. So negative correlation means that as one variable increases, another variable decreases. And they talk about this concept in this chapter as sort of a way to check your data. If you have a sort of an expected outcome and it doesn't, your results don't come out that way, then you can, that's sort of a clue to check your data. It's not a way, I mean, you may be tempted to change it, but that's not the purpose. You want to, if you expect a positive correlation, for example, and you end up with a negative one, then you might want to recheck your data before saying, oh, wow, this is a surprise. They discuss the continuing research problem. They say research is a cyclical, ongoing process. It would be rare for a psychologist or any other researcher in any other field to conduct a single research project and stop at that point because that one project had answered all the questions about that particular topic. Instead, one experiment usually answers some of your questions, does not answer others, and raises new ones for consideration. And they make a point that some people started out maybe as an undergraduate student and they fell into a topic that was very interesting to them and they made that topic their career, and that happens all the time. And I want to point out that those careers and all of the research that they have done, that's one of the important reasons, not the only one, but one of the important reasons why we must cite, we must give credit to people. Sorry, I'm trying to get it a little bit lighter here. Give credit to people for their work because they sometimes have spent their entire careers sharing their research with us, their understanding of the data. I think we would get this dark this soon, darn it. So they're saying that one good experiment often leads to another, and that's very, very true. But all this research that people put their time and energy into and their careers, it's very important. It demands that we give them credit. And then to close, I wanted to point out some steps they have on page 229. The research process. After reviewing relevant research literature, that's almost always the first step of any research study, is reviewing the literature. And that means that you go to, or go to your computer nowadays, but go to the library and do a search for as much relevant and possibly one slightly removed relevant journal articles and books that are related to your topic, or some of them that are slightly related to your topic. So you need to get a broad enough view of a particular topic so that A, you're not repeating a study unless you want to, that's already been done. B, you give credit to people that have gone before you, and C, that you have a good understanding of what you're trying to do a research study about. So a research or a literature review does take time. There's no other way around it. It takes time. You've got to read a lot. You got to look a lot. You got to search a lot. And you'll find a lot of stuff that isn't helpful. But sometimes you come across things and go, wow, that is so cool. I think I'll do that next. Or maybe I'll do that instead, or whatever. So you can find a lot of interesting things by doing your literature review. But that's the main way, not the only way, but the main way that research starts is by doing a literature review. and then they go on to the other steps. So that concludes my sort of discussion. Sorry it got so dark. My discussion about Chapter 10 and some of the highlights that I wanted to share, some of my thoughts. Thank you for your time and attention. And please post any questions you have or thoughts or anything else about this video in our class. Aloha!